Welcome, everyone. So this is a monthly RWG Exchange Cafe. We have some kind of an online event every month, either presentation or a combination presentation and discussion on different things. This month focuses on system security challenges. The presentation discussion will be led by Beth Wilson. And I want to welcome members of the System Security Working Group that are also participating in this session. So the meeting is going to begin with Beth giving a presentation, a summary of system security challenges when it comes to defining needs and requirements and verifying system of interest meets the system security requirements and validating that it meets the needs that deal with system security. And then open up the session for general discussion concerning system security, the topics that anyone want to bring up. And then next month, we'll have another session on November 16th, where Beth is going to kick off a project to develop some sort of system security guide that tailors what's in the Requirement Working Group products to address the system security challenges. One thing I wanted to point out, and the topic of system security is really important to anyone, the classic definition of system validation, validating the realized physical integrated system of interest meets its intended purpose and identify and assess its behavior and emerging properties in its actual operational environment when operated by its intended users. One thing that we've added in our products is a statement, and does not allow unintended users to negatively impact the intended use of the system, nor allow unintended users to use the system in an unintended way. And this phrase has also been added to the validation technical process in the upcoming revision to the System Engineering Handbook. I think this adds a little bit more emphasis on the importance of system security for all of our systems, not as an afterthought, but as part of developing any system of interest, given today's environment that we have. A little information on Beth. She earned her PhD in electrical engineering from the University of Rhode Island, retired from Raytheon, where she worked 33 years as a design engineer, program manager, research scientist, functional manager, and a test director on sonar, satellite, radar programs. She's a Raytheon certified architect and certified Six Sigma expert. She's currently an adjunct professor at WPI in their Master of Science and System Engineering program. She's INCOSE ESAP, chair of the Certification Advisory Group, co-chair of the System Security Working Group, member of System of Systems Working Group, and the Requirements Working Group. Some upcoming events for the Requirement Working Group. Like I said, November 16th, we'll continue this session talking specifically about tailoring what's in the RWG products to meet the unique challenge for system security. December 14th, we'll have a presentation by Henry Matfort on configuration management across a digital thread. This is a complimentary presentation he gave last January during our RWG sessions we had the week before IW. And then January, we'll have IW sessions. The scheduling is all TBD. One thing that is being emphasized by Tech Ops is to do a lot more collaboration between working groups during IW. Working groups can have some dedicated sessions, but they also would really like to have a lot of collaboration going on. So we'll talk about the status of RWG and some of the work that we're doing. One of the main projects, updating the Guide to Writing Requirements and producing a version 4 of the Guide to Writing Requirements. So with that, I'm going to turn the meeting over to Beth.
Just want to make sure that we're all using the same vocabulary. I pulled this from content that I developed for WPI, so that's a caveat I wanted to put out there. So these slides won't be posted with the YouTube video. So starting with the definition, system security engineering. In our handbook, we say it's ensuring a system can function under disruptive conditions associated with misuse and malicious behavior. And NIST SP 800-160 has a longer definition that makes it clear that this is across the life cycle of the system. And I think this is important, that it's not about just securing the system in its typical use. We need to think about how we apply system security during design to prevent unauthorized access, to be able to detect an insider threat, during manufacturing, where we're concerned about counterfeit parts, malware in the firmware, During installation, I did a number of system integration efforts, and while we were installing equipment, there was a lot of people around doing a lot of work around us, and so we had to be concerned about unauthorized access. While it's in use, we want to prevent remote access that's not authorized. We also are still concerned with an insider threat. Repair is often overlooked. This is where we're going to go in and remove some piece of the system or modify it in a way that we can debug it to determine what's wrong with it or to install updates. And so we're getting access to the equipment in ways that are representing vulnerabilities. When we upgrade systems, we may be connecting to new systems. And when we retire a system, we need to make sure that we remove all the information prior to the disposal. There's also a number of aspects of system security engineering. It's not one thing, right? So we have people who are experts in anti-tamper to prevent reverse engineering. We have people who are experts in supply chain risk management to address the supplier vulnerability, the counterfeit parts I spoke of, and malware and delivered software. We have information assurance. That's what I find people tend to think of first. How is your IT network free from vulnerability? There's also software assurance that's focused on software vulnerabilities. Hardware assurance is focused on hardware vulnerabilities. And operational security, identifying and protecting critical information. The key here is that you have to have expertise in all of these areas for system security, because you could have a great anti-tamper plan, but if you put it on a network that's not secure, so you don't have the IA there, it can be stolen. So that doesn't do any good to have one without the other. You can have a great hardware assurance, but it's not useful if your supply chain brings in counterfeit parts. Right. So you have to have all of these disciplines working together. Now let's talk about cyberspace. When we talk about system security, it's about all aspects of securing the system. And when we talk about cyberspace, that has brought in a different focus where we're looking at how the digital environment that's connected with networks and servers and systems and processes is part of the system. So when we talk about a cyber physical system, we're talking about a system that is integrating both the physical processes and software. So you've got hardware and software, but the behavior of the system is defined by both the computational forms and the physical forms of the system. And then a cyber attack is a malicious attempt to exploit vulnerabilities in either the information systems or the physical systems in cyberspace to damage, disrupt, or gain unauthorized access to these systems. And so in the context of cyberspace, system security is about both cybersecurity and cyber resiliency. So cybersecurity is where we're safeguarding not only the system, but the people and the organizations and everything from the cyber risk. And then cyber resiliency is the ability to anticipate, withstand, and recover from and adapt to adverse conditions that are enabled by cyber resources. So the system security focus is that the system can function under nominal and adverse conditions, and that we need to protect the system from a threat. So we need to keep the adversary out, and we need to be able to react to a threat. So we need to make sure that there's mission success if the adversary gets in. And that definition applies to a system that doesn't have any connections, the old form of system security that we called the guards and gates, as well as cybersecurity. So when we do a cyber risk assessment, it is not about just writing down a shall that says the system shall be secure. It's about identifying the critical assets that are part of the system, identifying the critical use case scenarios, those mission threads that describe what is important to the system. What are those mission threads that we want to preserve if we're under attack, identifying potential threats, and then pulling all those together into a cyber risk assessment. The graphic on the right shows that cyber risk is the intersection of the threat, the vulnerability, and the impact. If I have a threat on a part of the system that's vulnerable, but that part of the system is not important to the mission, then it's not really a risk. So I have to have all three to call it a cyber risk, but it also means that if I can reduce any of those, I can reduce the risk. So during this cyber risk assessment, we're going to develop risk scenarios. These are stories that describe a potential threat exploiting a vulnerability to impact a critical subsystem or component that's leading to a mission loss, right? So the risk scenarios are tied to loss scenarios. I call them misuse cases for the use cases. So these are loss scenarios that describe how a threat can affect our system and how an adversary as a threat source can attack our system and turn our use cases into misuse cases. So the example on the bottom left is where we have a real customer who we've developed this online shopping system, and they're able to browse what's in there. They can place an order, they can return an item, they could do all kinds of things interacting with our system. But that functionality, if there is vulnerabilities in it, a hacker would be able to access the system and steal the credit card information that our user used to place the order. So we have a use case for the user to place an order. We have a misuse case where an attacker steals information during that order. And we can also describe loss scenarios and misuse cases by themselves. The example on the right is something we had done with an INCOSE joint project with the System Security Engineering Working Group and the Product Line Engineering Working Group. We were looking at the maritime search and rescue missions, and we developed these loss scenarios where an adversary was able to disrupt the GPS signal, which would cause the search and rescue system to send the search and rescue vessels to the wrong location. So we had those loss scenarios that we developed. All right, so that's the background I wanted to present. What I want to show now are what I think of as requirements anti-patterns. So these are some of the things that we deal with as system security engineering enthusiasts. We want to help a team deliver a system that is secure, and then we encounter these kind of patterns. So the first one is what I call the cyber range. So you'll notice on the left side, I'm trying to map this with the requirements working group graphic. So we have a need established that the customer wants a secure system. And then we have some nebulous requirement that says the system shall be secure. But we don't decompose that. We just leave that as a nebulous requirement. And when we get to verification, well, there's no security shall, so we're good. And then when we deliver the system of interest into the intended environment during validation, we say, oops, I guess it wasn't secure after all. But early in the program planning, somebody had this great idea that we're going to send it to a cyber range. And so all the time somebody says, well, what about security requirements? No worries. We're going to send it to the cyber range and they'll give us a punch list of things to harden. And then later in the program, we hear we don't have time to go to the range now. Or worse yet, we can't afford to fix anything they might find. And if they find something, we'll have to fix it. So we're not going to the range. So the cyber range answer has always frightened me as a strategy for security requirements. Then we have the security controls. This is where we do develop requirements, but all they are is a list of NIST 800-53 controls. And then the verification is a checklist where we make sure we have all of those controls. We get to validation and we have the same outcome. Oops, it's not secure after all. So the requirements definition is that all we do is open the controls closet and pull everything out. So if we want to get the security certification, we need to make sure we include all the controls. That's what we hear when we realize we don't want security controls as requirements. This is what we look at as a compliance-driven approach, and it does not give us system security. Another is we'll ask security to review it after the design is complete. We don't want to bother them until we're done. All right, so we still have nebulous requirements, if any. They throw a security expert on the review team to look at the architecture. And the reason I mention architecture is because architecture is that transition from the design input requirements to the design output specifications in our requirements working group graphic, but also it's our best opportunity to influence the system security and system resiliency. So We allow somebody from system security engineering to review the architecture after it's complete, but it's difficult to change. So the architectural team will say, yeah, they identified some scary scenarios, but it's too late to change anything. So having a security review after it's too late to influence the design is an anti-pattern. Another is the non-functional requirement. So we have a needs statement that we want a secure system. And then we have security requirements. We have a requirement that the system shall do XYZ functionality securely. So somehow adding that word on the end makes it a security requirement. But what happens is when we get to verification, we verify the functional part of the requirement, and maybe we check for some basic security measures. And we're getting the same theme here. Oops, it isn't secure after all. So if we get to verification and we say, oh, yeah, I see a firewall, I see they require passwords, we must be all set, the non-functional requirements isn't doing it. Another anti-pattern is when we invite one security expert to represent every aspect of system security. So this is where we bring in an information assurance expert. That's somebody from IT who has all these IT credentials, and IT has many of them. And then we ask them to write anti-tamper requirements. Or we have a software assurance expert and they're reviewing a supply chain statement of work. Well, we had the security expert look at it, we're all set. There's many aspects of security. So what do we want? If those are anti-patterns, what would be the desirable pattern? When we do the needs assessment, we need to look at which mission threads are critical. These are the ones that must survive an attack by an adversary. In the requirements development effort, we want to develop the misuse cases, those loss scenarios, and then develop security requirements that define system capabilities to prevent those losses. So we need to treat security as a functional requirement. During the architecture, we need to review the mission threads as architecture products are being developed to identify and mitigate the security gaps during the development, not when it's all done. During verification, we don't want the checklist compliance verification strategy. We want verification where we confirm that the mission can be successful with misuse cases that represent those loss scenarios. I need to clarify, I'm not saying we shouldn't go to a cyber range. I think a cyber range is a good option for validation activities, but not as the way we'll identify the requirements that we need. Okay, so that's kind of a straw man of what we need. And then what I want to do is open this up to the discussion on the SSE perspective. Where does system security engineering fit in this graphic?
Like you say, the stakeholder real world expectations are for the secure system and all aspects of security that you talked about. Unfortunately, I find that a lot of the normal stakeholders and users aren't really versed in what system security means. So even though we elicit their needs and expectations for a system, like a lot of other abilities, they probably won't state them. They just assume they're going to be taken care of. So that means that we need to have the system security experts on our team to start with so that they can make sure that that's happened. Now, in this diagram, the lifecycle concepts and needs definition phase, before that, there's a lot of information gathered. And so in the needs and requirements manual, it talks about elicitation, but it also talks about identifying drivers' constraints, which includes your regulations and standards. And also, we're going to do risk assessment. And so all this information is together, and then it fits into this lifecycle concept needs definition process where, like you said, we're going to identify what the key risks are, but then we have to come up with a concept. So what's our lifecycle concept for how we're going to handle those risks? And then out of that analysis should come a set of specific needs that will be included in our integrated set of needs dealing with all those different aspects of system security. And then the transformation into design input requirements, then we're going to ask, what does the system need to do to address those needs? And then as design inputs, then those then are fed into the design process. And then the design team will have that set of requirements that you can actually verify against that dealt with security from the beginning. Now, one thing that we've found when you look at a lot of the standards, there's requirements on the system of interest being developed, but there's also requirements on the organization developing the system. And so these design controls, all these orange boxes at the bottom, are organizational requirements that tell the teams when you're doing these transformation activities, here's certain things you need to consider. So one of the things that we'd have to do when we're talking about system security is address within the organization what are requirements on the organization that's doing all these transformations when it comes to system security. And so there's really two sets of needs and requirements, one on the system of interest, but also one on the organization producing that system of interest. And once we get into operations, there should be a set of requirements dealing with security on the operators, the maintainers, and disposers. So there's different kinds of requirements that'll be documented in different places, and they all need to be addressed in terms of system security.
I've stared at this diagram long enough that it speaks to me, but some of our system security engineering friends, this may be a new concept. But to Lou's comment about the organizational requirements, one of the things as we start from the left, going from the stakeholder real world expectations, and then move to the integrated set of needs, and then move to the design input requirements, that loop of requirements verification, asking if they're defined correctly, this is where we can influence, say that an organization needs to detect those anti-patterns. No, it's not controls. We want to see system security written as a functional requirement.
It's absolutely everywhere. I've worked this
Agreed.
space. I've worked this space for what seems like forever. And I've worked programs and they ask me, what documents do you want for your security assessments? I said, I want everything. I even want the cost volumes, because are you spending enough to really meet the whole thing? And they always object when I say I want everything and doing assessments. But it's like, no, I really do want everything, because it's amazing where things can get buried that tell you about what their thinking is and the reaction to that. One thing I would bring up, and this goes back to your loss scenario too, and just kind of expands on one part of this whole everything. Right there on the left side with the clouds, stakeholder real world expectations. One thing we need to do is, before we even have a concept of how we might execute the system so that we can do the loss scenarios, and I know that's not always the case that every system development we do has that kind of situation, but that goes to eliciting what are those losses that they cannot live with. If I can't tolerate any loss, okay, that's something I need to document. If I could tolerate not having the capability 1% of the time, every other Thursday, blah, 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 okay, that's something we document. Because those become the losses we care about. That drives what we're going to do in terms of requirements and those percentages of uptimes and all those kind of aspects. A lot of times we may not know the scenario where we'll lose that. Sammy Sajera in his book, Engineering Trustworthy Systems, says you got to think that loss will happen. You may not know how it happens. You may not know the scenario it happens. It may be happen. And so some of our requirements are dealing with losses that could happen, but we just don't know how they happen. We have no clue. And we need to consider that.
You put something in the chat that the IST 800-160, the first volume, will give us some insight, because one of the things that we want to put in the guide is in the requirements guide to needs and requirements. We talk about these kind of activities. I think NIST 800-160 will help us do that translation so that we can use that as a starting point for the requirements guide.
The update will be any day now. Yeah, for those who know the history, revision 1, and Beth got drafts and all that. So I'm a co-author of revision 1. And I keep like, why isn't this out yet? I keep peeking. It's like, why isn't it out yet? Well, I do work for NIST, but as an FFRDC contractor, any day now is what I keep hearing now at this point.
Volume 1 is basically the guide to system security engineering. And
Right.
Volume 2 is where we get the concept of the cyber resiliency for
Right.
the systems.
This is Rick Bell. Lou made a point of saying that your stakeholders aren't especially educated enough to know what to ask for in terms of security needs. And so my question is, how do you get the proper needs elucidated if, number one, asking your stakeholders isn't sufficient, and number two, you're under contract that doesn't require it, and therefore it's viewed as extra cost?
That's part of the organizational piece. Both the acquirer and the supplier need to be educated in the need for this. So if a customer contracts out for something and there's no needs or requirements dealing with system security engineering, then you have an incomplete set of requirements. If the supplier is educated in that, that's one thing they should push back on. The definitions that we have for requirements is it involves an agreement between the acquirer and the supplier. And so a lot of it's going to be an education thing. The customer has to understand the need for this and what the consequences are. So like in the previous discussion, what could you not live without? What are those negative scenarios? On the post, someone said pennies early is cheaper than big bucks to handle. So it's really an investment. And if the customer deals with the problem early, it may cost $1, but if they wait until the end and find out during validation, like Beth was showing, and they get hacked and they lose all their data, they got to pay a big ransom thing. Now they're going to pay 100 times more than if they would have addressed it. So there's this big education thing that's in there. And then that's where on the bottom, the organizational requirements for product development need to include system security engineering aspects in what they're doing, both on the customer side and the acquirer side.
So Rick, do you have ideas? Because I think we see some techniques being proposed to be able to describe loss scenarios and what would be the functional requirements associated with them.
I don't have a sufficient comprehensive set of ideas. That's the first thing I'll say right now. We're working on those, trying to figure out something reasonable. But more importantly, we're trying to inspire people to think about the need for doing this so that we will have a variety of different approaches attempting to do this and be able to sort through some of them later on and find out which ones work the best. Discussions with some people who are working very closely on government contracts. And basically, the pushback they're giving us is that government contractors don't want to do this if the contract doesn't require it because of the cost. In trying to figure out, so how can we make it zero cost, right? I mean, there's two aspects from my perspective on this. One is you're looking at a bunch of stakeholders, and I'm viewing stakeholders not as those people you have to listen to, but rather those people who are affected by or will affect the security of the system, which is not necessarily those you have to listen to. A number of stakeholders in those categories. First thing I want to inspire each one of them is that there is value to them directly in developing a needs-based security requirements understanding, as opposed to any other kind of base. And the concept of needs and loss works very well hand in hand, I think, in terms of trying to get people to think, well, what can you not afford to lose? That's a need then to protect that. And I believe that all those stakeholders are going to do some form of requirements engineering anyway. I know that's not totally true, but let me just assume for the moment that most of the stakeholders who are interested in will do some form of introspective requirements analysis. And therefore, all we're saying to them is, instead of doing it the way you were doing it, do it this way. It will cost you the same, but you'll get a better result. And so that's a zero cost aspect right there. Then the next aspect I'm concerned about is, so if that was individually, every one of those necessary stakeholders is willing to take a needs approach instead of a what I have and what knowledge I have approach. The other part is, how do I get them all to have some sort of an alignment and agreement on what collectively they should work together to make sure occurs? That's the part I don't understand how to fund yet, because if it's not being done and if it's not required, nobody wants to pay for it.
I think you make a good point, Rick. That's one of the themes, like in the needs and requirements manual, especially in the section 4, we talk about lifecycle concept needs definition. The word security is mentioned multiple times along with safety. And so during elicitation, the project team is encouraged to ask the stakeholders about their security needs. If you ask them, they'll tell you, but if you don't ask them, they just assume you're going to take care of it. One of the goals for a guide in system security is so that the practitioner of systems engineering, both the customer side and the supplier side, give them guidance hands-on. So if I'm a new engineer and I'm in the customer side and I'm supposed to be coming up with defining needs and requirements for the new product that I'm going to contract out, this guide is going to inform me that that's one of the areas that I have to address. What kind of questions should I ask? What are the different areas I need to address? The guide is a practical thing that you can give to any of the practitioners to help them get through this, because it is a specialty engineering area. So we need to give people practical guidance. There's tons and tons of standards and regulations about system security, but that'll put people to sleep. And so we need some way to address the issues that you're talking about in a practical manner that both the customer and the suppliers can use as guidance when they're going through this.
To that point, Lou, I wouldn't ask it in terms of what are your security needs. They're going to look at you like deer caught in the headlights sometimes with those kind of questions. I think from a practical standpoint, it gets back to asking two sets of questions, one about where the losses you can tolerate and picking that out. And then it's understanding their operational environment and the adversity, and whether they know it or not, at least you have a basis to go off and think about the adversities they will face in that environment. And they got to be able to handle those adversities. I say adversities and saying adversaries and all that kind of thing, because there are all kinds of things that can cause a loss. And sometimes it's a combination of somebody with ill intent with a human who accidentally does something, or a weather, some sort of condition that they take advantage of. So you can't just stovepipe the malicious versus the non-malicious and kind of analyzing that. So that loss, that kind of thing. So that's part of that. The other aspect too is when you start though taking that approach, it becomes a situation on the left we kind of ignore. When I start thinking in terms of loss and all that kind of thing, these things start blending safety and security and any number of other things that deal with loss. And that's not a bad thing. Ross Anderson, in the third edition of his book on security engineering, made the observation that with everything being connected now, if I'm going to deal with safety, I cannot avoid dealing with security anymore. His observation from his perspective where he sits is that those are ecosystems that are beginning to merge, in fact. So giving a security guide on this, it's really going to be hard to separate that from safety and other basically illities, if you want to use that word.
Oh, yeah, definitely. Prevent an unintended user in using the system in an unintended way. That could be with loss, but could also be a big safety thing.
Exactly.
Flying an airplane into a building, hacking a drone and having the drone go do something. There was a short-lived TV show 3 or 4 years ago. I think it was FBI cybersecurity or something like that. And they had a bunch of case studies each episode. Like one of them was someone hacked the brakes on a train, and they were able to accelerate the train, disable the brakes, cause something. So it was a security issue that allowed that, but the effect was a safety issue. Just like you're talking about, the effect as a loss is something. Loss of life is a loss too.
So I remember that. It was CSI Cyber. So Ken had his hand up.
Wanted to contribute towards the life cycle cost considerations. By all means, we need to get security considerations, safety considerations, and others in the early stage of the life cycle. The classic, as it was termed for some time, baked in instead of bolted on after the fact. But the opposite end of the life cycle is also important. When you get out towards the end, towards disposal of information or of hardware may not only be a military classification consideration, but often has severe restrictions for commercial activities on ownership of rights and things like that. So you have to design for both ends of the life cycle.
That was one of the things I was talking about with system security engineering has concerns throughout the life cycle. And some of the vulnerabilities we introduce in the system are because we are not thinking of those use cases outside of the operational use, and we need to think about disposal.
Yeah, my experience quickly is that not only do people have a tendency to say, well, I won't take that to the cyber range because I'm afraid of what I'll find out. They also say, I'm not going to worry now about security requirements downstream because I don't know when that will be, and it will not be my watch. They kick the can downstream and let somebody else worry about it. Neither are acceptable.
Right.
Okay, the other thing I wanted to raise is one of the things that we've been doing in the Resilient Systems Working Group is trying to structure our requirements such that there's a consistent way that you can form them and potentially even do quality metrics on the goodness of your requirements. I would suggest that the SSE group consider much the same. How do we have consistent security requirements structure, not content, but structure? And how do we measure the goodness or usability of those requirements would be another contribution I'd like to talk about at some date.
So do you have material from the Resilience Working Group that you could share with us?
Yes. And in fact, John Burtis has, I believe, made a presentation to this group, to Rick Dove, if not to others, about how we structured requirements and expressed them in terms of natural language, in terms of other methods as well. Would love to make a presentation on that as a suggestion.
That may be of interest to the Requirements Working Group in general.
Yes.
And that would be a good collaborative activity at IW, maybe.
Absolutely. I
That would
agree
be a
with
collaboration between Requirements, SSE, and Resilience.
Absolutely. And that's one of the things which we would like to, shall we say, contribute to the rest of the INCOSE working groups. And that is, there are ways of doing things that I think will enhance all of our efforts.
If
Yeah,
you
that's
do
good.
that, I bet I can find a sponsor that will pay my way to IW. I like this.
Oh,
I'll
absolutely.
take it to
Mark.
Melinda and go, hey, you should pay my way here. They're going to talk about this.
Yes, absolutely. And I'd love to have you there at the IW in person. But again, from a contribution viewpoint, not only for system security, but for requirements, I believe that some collaboration amongst the groups will provide benefit.
Yeah, that's good. A different topic, Evelyn, I want to respond to your note in the chat where you're saying, while no one's paying for it now, it might be the loss of future projects if delivered with poor security measures. The issue that the contractors have is that if they bid what they believe would be necessary, they will lose the contract to someone who doesn't bid what was believed to be necessary. That's where the dilemma comes in.
I was thinking more like if there are costs that we would just have to cover ourselves and not even put it in the bid. If we understand that the customer doesn't know what they actually need because we have more security understanding than they do, and they haven't put it in their requirements, then what if they end up with a poor performing system because we didn't do the work? But it means we would make less money for this project. But if it overperforms and they realize this was a much better solution, they would choose us the next time too.
And that sounds good. And in fact, I actually have had government program managers look me in the eye when I was still working and say, well, you should just do it because it's right. Oh, so I should do it even though you're not willing to pay me for it. We should just make this some charity event that my organization does for your project.
But remember that I work in a different business environment than you do. I'm in Norway, and
Okay.
It's not the US. It's not as harsh and competitive, I think. So there is a difference there in the context of operation.
It's also a bigger picture. It's really complex. So Mark made a comment about the lower level security requirements may drive higher level non-security requirements. And so the overall behavioral system is a function of the interaction of all its parts. So if the supplier defines requirements that were not a part of the customer requirement set dealing with security, that's got to fit into the overall system, and it could impact other requirements. It could have an impact on performance in some cases. And when it comes to verification, now all those new requirements, someone has to pay for the verification the system met those requirements. And then when it comes to validation, how much of that is the supplier's responsibility? And often a lot of validation the customer assumes. And now you've added stuff that wasn't in their original set of needs that you're validating against. And so there's a big ripple effect in doing something that wasn't required by the customer, even though it's the right thing to do.
Yeah, so the only conclusion I can draw when thinking in those circles is that trying to educate the supplier on this issue is the wrong path. We have to educate the acquirer.
Agree. A lot more than just that.
It is a lot more than that. And to Beth's example about two government contractors bidding each other, one includes security, one doesn't, that gets beyond requirements. So that kind of gets beyond the domain here. One thing we're finding with work I'm doing for but our government client, we're looking at standardizing the practice for security and trying to say this is the standard way we want to do it across the thing. So that means that both sides are bidding to the same amount of work when we have that. But without that standardization of practice with the accompanying standards to the engineering efforts we expect, then yeah, we're going to have that inequity of, oh, he doesn't bid it and she does, so cheaper wins. They're cheaper because they're not accounting for what they should be doing, what's right, because right's not mandated.
That points to what Lou was describing earlier on the bottom of this slide, that the standardization of practice would serve as the organizational design controls.
Yeah, okay, yeah, you're right. So we've gone back
Okay, so
full
that's-
circle.
So that is a way to address it. And I have to say, we've been talking about the defense examples, but it's also in commercial. I do a case studies class, and one of the case studies we do is when the internet went down, when the IoT attack on Dan. And that was basically all of these Internet of Thing devices. And in the commercial world, it was cheaper for them to make it if it didn't have a password, so there was no security as part of it. And the business model was, if we make our system secure, they're going to buy the other product, because the customer, this gets to the stakeholder again, doesn't know enough to ask about security. So they're going to buy the cheaper product that's not as secure. So it's not going to do us any good if we're not in the business at all. And it's only been since some of the device standards have come out that we're starting to see more security in IoT devices.
That's important, like in medical devices now,
Right.
where they're finding out that if someone hacks into a system, you could overdose someone. One of the big things the FDA is concerned with any medical device is that risk assessment up front. And if cybersecurity is the risk, the FDA expects the device manufacturer to address that risk and to show proof that they have addressed that risk. And the FDA is really waking up as that is a key risk. So that's something they're looking at, the medical devices. And one of the problems, in a way, we have with INCOSE is that while it is a big piece when you have the acquire supplier role, we do have a lot of organizations that develop stuff in-house. And so they are their own customer, if you will, for the development in-house kind of things. And so from an education standpoint, like Rick's talking about, whether you're a customer for external or you're the customer for internal organizational things, you still have to be educated up front and understand what loss could mean to you and that you're going to deal with that up front, because it's not something you can add on later.
Right. So what I want to do is move to the last slide and invite us to continue this discussion in November when we kick off the project that says, how does the system security engineer use these requirements working group products, the needs and requirements manual, the guide to writing requirements, the guide to needs and requirements, the guide to verification and validation.
Anyone have any parting thoughts before we end the meeting?
The only thing I want to say is that I want to start making plans right away with you guys at the Requirements Working Group on how we're going to deal with IW collaboration.
If you could send an email to Tammy Katz, she's the chair of the working group, and she's the one that's going to be putting together the schedule.
I can make the introduction, Rick. I have her email.
We're becoming really popular, and we've got about 4 or 5 different working groups that are wanting to collaborate with us on different things. And so we're going to have a full IW.
Yes. Ken Kiriton here. I'd like to collaborate as well or add to that distribution.
And by the way, Tammy and John Burtis met and talked about this topic within my earshot at the Western State Regional about this thing that Ken suggested that be presented. So if you hear it twice, it's because Tammy and John talked directly.
I received that email, and it's about requirement templates.
Yeah.
That's something we'll need to talk about. So with that, I'm going to stop the recording.
Thanks, everyone.
Thank you, everyone, for your time.
Thank you.